But let's do number 26 right now. 26. Alright, let's write all this stuff down. Let's write the given. This is really, really close to what we just did, but it would be good to do it again just to kind of get you going on this. Angle 2 equals angle 3, and you want to prove again, we're trying to prove that two lines are parallel to each other. As soon as I see that, I'm thinking, okay, well, what's probably going to be one of my last reasons? One of my last reasons is probably going to be that either corresponding angles are equal, alternate interior angles are equal, alternate exterior angles are equal. Okay, that's probably going to be one of the choices that I'm going to have for this. So that's you got to be thinking the whole time. And let's see, this goes like whoops. It goes like that. So the picture even looks pretty close to the same. That's alright. I don't mind doing two in a row that are kind of the same. Again, since we're first learning this stuff. There's 1, there's 3, 2, 4. And that's W, X, and this one is Y, and this one is Z. Alright. We're good to go. Let's mark the picture up. Okay. Here we go. WX, this top one, and YZ, this bottom one, are parallel to each other. So let's mark them parallel. Alright, so we can visually look at it. When we look at the picture, we know without a doubt which ones we know are parallel. It's given that they're parallel to each other. Angle 2 and 3 are equal to each other. So angle 2 and angle 3 are equal. And we want to prove that the other two lines, WY and XZ, we want to prove that they're parallel to each other. Alright? This is almost the same proof, isn't it? It's pretty close, if not exactly what we had before. So let's do a statement of reason thing. 2 columns, right? That's what we call them. So there's 1 column. There's 2 columns. Oops. There we go. And just for the sake of time, I'm not going to put statements and reasons. Let's just put S and R. You should write statements and reasons, but just for the sake of time, we're doing this. Okay, so here we go. Let's see what we know. We know 2 is equal to 3. Is there anything else that we know? Because these two lines are parallel right here. Look, this line, and this line are parallel to each other. So what does that tell you, Nate? What do you think? Well, knowing these two lines are parallel, okay, it's given, right? It's given that this and this are parallel to each other. From that information, what else can we look at and say must be true about this? Okay, Nico, what is it? 1 and 3 have to be equal. That's right, because look, if this line and this line are parallel, look, this is a transversal, isn't it? Again, if you need to go off to the side and redraw it, look, there's my top and bottom line. There's my transversal. So what must be true about 1 and 3? If this line is parallel to this line, what must be true about 1 and 3? They got to be what? They got to be equal to each other, right? Yeah. And give me a reason. Why must they be? That's right. Because if you have parallel lines cut by transversal, then the alternate interior angles have to be equal to each other. You with me on that? So look what we got so far. I've got 2 is equal to 3, and 3 is equal to 1. And you can go in any order, I guess. Watch. Yeah, let's go 2. Yeah, let's go 2 equals 3, 3 equals 1, so what?
1 equals 2.
2 equals 1 or 1 equals 2, right, exactly. And what reason would that be? Think what we just did. Right, okay. We went, guys, let's not do this, alright, because that discourages anybody from even answering out. So, alright, I know you're messing around with him, I know you're friends and all that stuff, but let's not do that, alright? Doesn't make it for a good atmosphere. Watch, if 2 equals 3 and 3 equals 1, then guess what? 2 equals 1. Or you could say 1 equals 2. It doesn't make any difference, does it? Okay, 2 equals 1, 1 equals 2. So, and that's transitive properties, like A equals B, B equals C, A equals C. You follow me on that? Alright, now, big deal. What if 1 and 2 are equal to each other? Who cares? Well, we do, because what? What are they? What's the relationship between those two angles? They're corresponding angles, aren't they? They're corresponding angles. What are my two lines that make those corresponding angles? It would be WY and it'd be XZ. Do you see that? These two lines, watch. Again, if you want to redraw it, these two lines here, oops, that's pretty bad. There's your transversal. Where's 1 and 2? 1's right here and 2's right here. If these are equal to each other, guess what must be true about these two lines? They got to be parallel. Isn't that what we're trying to prove? Absolutely. Okay? It's a little bit different, isn't it? Just a little bit different from the other one, but really, really close. So let's write the stuff out now. What do you want to write first? Let's do... Yeah, but again, I don't want you to think that you always just stick the given at the beginning all the time. I want to go in a certain order, okay? What'd you do first? You went 2 equals 3, right? And then you went, what? 3 equals 1. So angle 2 is equal to angle 3. I'm going to write that first. Doesn't matter. You can put the given in, you know, it doesn't matter which one goes first. But I'm just trying to go by how we're proving it. Because I'm looking at this, I'm saying, okay, 2 equals 3. Well, that's what I'm going to start with, okay? So 2 equals 3, then 3 equals 1. But before I can say 3 equals 1, what do I have to say? I got to say that what?
WX and lines are parallel.
Yeah, I got to say that these two lines are parallel to each other. So we got to put that in there. So WX is parallel to YZ. And that's all given. All right, so there you go. So 2 is equal to 3. Now, these lines are now parallel. I've said it in my proof right here. Now what can I say about 3 and 1? Well, now I can say that they're what to each other?
Equal.
They're equal to each other, okay? They're equal to each other because what? Alternate interior angles, okay? So 2 equals 3. Now I can say 3 equals 1 since I've shown my lines parallel. If I didn't say these two lines are parallel, could I say 3 and 1 were equal to each other? No. The only reason I know they're equal to each other is because I got parallel lines cut by transversal. The alternate interior angles are equal. So now I can say 3 equals 1. So watch. Angle 3 equals angle 1. Look what I have. 2 equals 3. 3 equals 1. Then guess what? 2 equals 1, right? Or you can say 1 equals 2. It doesn't make any difference. What's my reason for that, though? Oh, by the way, I forgot this. Why is 3 equal to 1? That's right. Alternate interior angles are equal. Okay, alternate interior angles are equal. Technically, now we're shorthanding it a lot. Technically, it would be if two parallel lines are cut by a transversal and the alternate interior angles are equal, then I'm sorry. If two lines are cut by a transversal, then the alternate interior angles are equal. But do you want to write all that stuff? No. So I just shorthand it and I just say alternate interior angles are equal. But you have to know that you got to show the parallel lines first. Do you understand? You cannot have this step right here before this step. You can't say 3 is equal to 1 until you've established that those two lines are parallel. Make sense? Okay, so make sure you say the lines are parallel, then you can say those two angles are equal to each other. So order does matter in a lot of these situations. Sometimes you can change the order of things, but in this particular situation, you have to say that the lines are parallel before you say those two angles are equal. Make sense? All right, now 2 equals 3, 3 equals 1, 1 equals 2. Why does 1 equal 2? It's not corresponding. What is it? Transitive, right, because look what we did. We went 2 equals 3, 3 equals 1, so 2 equals 1. If A equals B and B equals C, then A equals C. That's basically what we said right there, isn't it? All right? And that's transitive property. We use that quite a bit, so look for that. It's not used in every proof. So far it has been, but it is used quite a bit. So we call this the transitive property. All right? So now 1's equal to 2. We're good. So if 1's equal to 2, then guess what? They're corresponding angles, aren't they? So what must be true about these two lines if 1 is equal to 2? They got to be parallel. So I can go right to my parallel thing. So WY must be parallel to XZ. And what's my reason for that? Yeah, look before. I said 1 and 2 are equal. They're corresponding. If the corresponding angles are equal, then the lines are parallel. So my reason is the corresponding angles are equal. Now, technically, listen to me. I'm letting you do a lot of shorthand kind of thing, shortcut stuff. But what does this theorem really say? It says if two lines are cut by a transversal and the corresponding angles are equal, then guess what? The lines are parallel. technically, that's all the stuff that you should write down. That's your reason. Okay, or you could say it's the converse of the corresponding angle postulate. Do you remember that? The corresponding angle postulate? But I like to just say corresponding angles are congruent. I think we all understand what that means. It means if the corresponding angles are congruent, then guess what? The lines are parallel. Get it? I just don't have to write all that in. I'm fine with just saying this right here. And then that's it. That's our proof. We proved that this line and this line are parallel to each other. Okay? Yeah, absolutely. Yeah, that's the whole roadmap story, okay? Go through it first, okay? Know where you're going with it first before you actually start writing the stuff down, all right? Think through it. Draw the stuff out. If you need to do little sketches like this, you might say, okay, angle 2 is equal to angle 3. Angle 3 is equal to angle 1. And then it might just pop into your head. Once you see it written down, you might be like, oh, yeah, look, 2 is equal to 3. 3 is equal to 1. So guess what? 2 and 1 must be equal to each other. All right? Do you follow me on that? Some of you might be able to just do that in your head. Some of you need to jot down little notes. Okay? Take little, just write down this stuff right here. That might help some of you guys. You might not see it right away because of all the other junk in the picture. Sometimes just isolating the angles that you're working with really helps out. All right, so you might want to do this kind of stuff. This is not all part of your formal proof. These are just little notes that you take for yourself, right, just to make the stuff pop out a little bit and stand out a little bit to you. Okay? So what do you think? Is this a little bit better than when you first walked in today? Yeah, give you a little bit of better. I told you, it's a slow process. It's a process. You're not just going to be able to figure out how to do this in one day. It's a process that takes a little bit of time. We got about 5 more minutes. Let's try one more. Yeah, let's do 28. That's the one I had written down to do. So let's pause this. All right, here's our situation. We've got this quadrilateral, and let's mark the stuff. Angle 1 is equal to angle 2. So I mark angle 1. And I come over here and mark angle 2. It also says that LJ, that's an L, line segment LJ, where is that? This one up and down, and ML, this is one on the bottom. It says they're perpendicular. So if they're perpendicular, what kind of angle do they form then? A right angle. Okay, now they do this in the book, that they put that little right angle symbol, but I saved it because I wanted you to see that they're perpendicular. Now what are we trying to prove? We're trying to prove that KM is going to be perpendicular. Now, if you remember, you might have to flip back a little bit. I flipped back before you guys came in. I think it's on section 3.2. There was one theorem. We hit it fairly quick. We didn't talk a whole lot about it, but it kind of looked like this. Do you remember this? If I had 2 parallel lines and I had a transversal, and if it was perpendicular to one of the parallel lines, then guess what? It's going to be what? Perpendicular to the other one. Okay? You follow me? So, what did that say, though? It said that I had 2 parallel lines, right? I have to have 2 parallel lines first. In this picture and in the given, do they tell me that these lines are parallel? No, they don't. But if they do tell me that 1 and 2 are equal, you see what they're doing with you here? So if angle 1 is equal to angle 2, tell me something about some lines. Tell me about this line right here and this line right here. That's right. JL, not perpendicular. Parallel, right. So JL must be what? Parallel to KM. Do you see it? See, that's my transversal, LK right there. And so this line and this line must be parallel to each other. So guess what? If JL is perpendicular to LM, and if KM is parallel to JL, then tell me something about KM. KM is going to be what? Perpendicular to LM as well, because of this theorem right there. And they actually have a name for it. They call it the perpendicular transversal theorem. All right? So I know I'm going quick because I only have like a minute left. So let's just write it down. Watch. Angle 1 equals angle 2. It's given. And watch. I'm going to split up my given. All right? I told you don't have to, put them all at the top right here. Now what I do? So I marked it, and then JL is parallel to KM. Now the reason I did that, if JL is parallel, well, it's parallel because 1 and 2 are equal to each other, all right? And why? That's alternate interior angles are congruent or equal. I got to do this quick, sorry. So JL is also perpendicular to LM. How do we know that? Because it's given. I tell you what, I'm going to write it all out and then just flash it on real quick because I'm running out of time. Okay, there's your proof, and I'm going to give you a little worksheet to work on tonight for extra practice.